All right, in this video I'm going to do the second part of the lesson on permutations, and I just want to kind of go back to what we just did. In problem number 6, we had to choose a president and a vice president from 7 students. There were 7 ways to choose the president and 6 to choose the vice president, which means there's a total of 42 ways to choose both in that order. And we did something similar on number 7. Here it's MVP, most improved, and team player. We had 12 players to start with, so there's 12 to choose from for MVP, and now there's one less, 11 to choose from for most improved. And once we've already chosen these 2 guys, there's now only 10 players to choose from for our team player. And so there's 1,320 ways to do that. So we're just using the fundamental counting principle to do these problems. Now, when we got to number 8, the numbers got bigger. Whoops. Actually, let me go to this paper. So it seems like maybe when the numbers get bigger, it'd be nice to have a formula for this kind of thing. And sure enough, we do. So let's talk about the number of permutations of n things taken r at a time. So the number of possible permutations if r items are taken from n items is, and here's our formula. So this is the number of permutations of n things taken r at a time. So it's n factorial over n minus r factorial. Now, one thing I should mention here is that 0 factorial will equal 1. In fact, so does 1 factorial. Let's go ahead now and do some of these problems. So, actually, I'm just going to leave this right there. So using the formula, the number of permutations of 7 items taken 2 at a time is going to be 7 factorial. And let's see, in this case, n is 7 and r is 2. So it'll be 7 minus 2 factorial in the denominator. So this is 7 factorial over 5 factorial. We've learned how to solve problems like this. This is 7 times 6 times 5 factorial over 5 factorial. The 5 factorials cancel, and we get 42. All right, I would encourage you to try the other 3 and then watch the video. And do these by hand. But I'd also encourage you to see if you could put them in the calculator, and I'll show that to you. Actually, I should do that right now before we start. Okay, so for 7 permutations taken 2 at a time, the number of let's say that, see if I can say this right. The number of permutations of 7 items taken 2 at a time. So that would be I think we want to put the 7 in first, and then we'll hit probability, and we'll choose NPR. That's what I call it. And then we'll put in the 2. And notice you do get 42. All right, so let's go ahead and, like I said, work on those problems and then check your answers. All right, let's see how you did. So here, this is 12 factorial over 12 minus 3 factorial, or 12 factorial over 9 factorial. Well, that's going to be 12 times 11 times 10 times 9 factorial over 9 factorial. These guys cancel. 12 times 11 times 10, you should get 1,320. On this one here, it's going to be 7 factorial over 7 minus 7 factorial. and that's going to be 7 factorial over 0 factorial, which we said is 1. So we get 7 factorial over 1, or just 7 factorial, which is 5,040. All right, last one. So this is the number of permutations of 7 items taken 0 at a time. So this is 7 factorial over 7 minus 0 factorial. Well, that's just going to be 7 factorial over 7 factorial. Any number divided by itself is just going to be 1. All right, so that's our calculations. And again, you should also make sure you can do these on a calculator. I'll just do letter B real quick. So again, you got to hit the 12 first, and then the probability button. We're choosing option 1, or in this case it's already highlighted, so you could hit enter, and then put in the 3. And notice we get the same answer. All right, let's move on to numbers 10 and 11. Well, actually, I want to go back. I almost forgot here, and look at number 8. So this is 120 items, or in this case it's swimmers, taken 12 at a time, since we're giving awards or ribbons to the top 12. And so if you put this into your calculator, you will get that answer. So that is the formula that we can use on that problem. So here we had 120 swimmers, and we want to find the number of permutations of those 120 swimmers if we choose 12. Or we say choose 12 at a time. Okay, so on number 10, it's the same kind of problem. In an office of 10 people, 2 are chosen as Employee of the Month and Team Player of the Month. In how many ways can this be done? So one of the things I want to just remind us of here is order matters. Being Employee of the Month is different than being Team Player of the Month. I would want to be the Employee of the Month. So anyway, order matters. And this is the number of permutations of 10 items taken 2 at a time. So this is 10p2. And so that's 10 factorial over 10 minus 2 factorial. So notice in this problem, n is 10 and r is 2. And so this is 10 factorial over 8 factorial, or 10 times 9 times 8 factorial over 8 factorial, and you get 90. So there's 90 ways to choose the 2. So go ahead and try number 11 now. It's very similar. All right, so let's see how you did. So here we want to find the number of permutations of 20 items taken 3 at a time, because we're pretty much saying how many ways can this be done. So this is 20 and then the p and then 3. So this is, and I'm just going to go ahead and use the calculator here, but you could do like what we did up here. You should be able to do both. Make sure you can do both. So we'll put in the 20, and then we'll hit the probability button and choose option 1, and then 3. And so we get 6,840 ways. Now, I just want to say, this is the formula, but I would remind you that we also have another way, and honestly, it's more basic and more simple. We're making 2 choices here from 10 people. So for Employee of the Month, we have 10 people to choose from, since there's 10 people. And now once we've already chose that person, there's 9 left. And so this is just the fundamental counting principle. there's going to be 10 times 9 ways to do both or to select both of those in that order, so 90 ways, which is what we got. And similarly here we have 3 positions. So we have our top favorite, our number 1 favorite. There's 20 to choose from for that, and then 19 left over to choose from our second favorite, and then 18 to choose from for our third favorite. And if you multiply that out, you get the same answer. All right, so it's a good idea to understand how to solve those either using a calculator or just by using the fundamental counting principle. All right, let's move on. So permutations of duplicate items. So if you look back to what we've already done, or when we're talking about permutations, remember we said they were distinct items. Basically, there were no repeats or duplicates. So that's not true here. So how are we going to handle that? So it turns out we have another formula. So I'm going to see if I can help us understand how the formula works. So basically, if we arrange Bob, we could have B and then the O. Well, we have 2 B's and an O. So it could just be B-O-B. But keep in mind, there's 2 B's. So we'll just use subscripts to describe the 2 B's. So we could either have the first B, O, and then the second B, or it could be the other way around. So you could say there's 2 permutations of the B's. Or we could have the case where we start with the 2 B's. I'll say B sub 1 and then B sub 2. And then we'll do it in the opposite order, B sub 2, then B sub 1. So again, we have 2 B's. We're not sure which one will come first, but there's 2 permutations there, 2 orders. And then the last case would be when you start with the letter O, and then you could have the first B and then the second B, or it could be the second B, then the first B. Now the thing is, we don't have subscripts on the B's. So this option is the same as this option here. So in fact, we only have 3 distinct ways that we can arrange these letters. So how do we, let me go ahead and write 3 ways. How can we use a formula to do this kind of thing? Well, here's our formula. The number of permutations of n items, where p items are identical, q items are identical, r items are identical, and so on, is given by this formula here. So n factorial over p factorial times q factorial times r factorial. So let's go back to the one we just did. Notice there's 3 choices that we're making. We have 3 items, 3 letters. So that's our n factorial, that's 3 factorial. Now the B's, are the ones that are repeated. And there's 2 of those, so we're going to divide by 2 factorial here. So basically what's happening, 3 factorial is actually 6, and that's our 6 permutations. However, we got to divide out these permutations of the B's. And so that's what we're doing here. Because for each of these, there's 2 permutations of the B's. And so here we divide out the permutations of B. And so this becomes 6 over 2, or 3, which is what we got up above. All right, so let's go ahead and do the same thing on number 13. In how many distinct ways, different ways, can the letters of the word Tennessee be arranged? Well, here we have how many items? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 items. So our numerator will be 9 factorial. Now let's see, if you look at the e's, there's 3 e's, so we're going to have to divide by 3 factorial to divide out those repetitions of e, or permutations of e. Then we have 2 n's, so we'll have to divide by 2 factorial because of the 2 n's. So let's see, we took care of the e's, and I made a mistake there. There's actually 4 e's. So we're dividing by 4 factorial. For the n's, we had 2, and for the s's, we had 2. So if you plug that into your calculator, you get 3,780 ways. I'm going to go ahead and do that just so you can see it done on the calculator. So we'll hit the fraction button first. And then we'll hit 9 factorial. So remember, we got to go to that probability button and hit 3 for option 3. And then go to the denominator, you'll hit 4, and then the probability button, option 3, and then 2, and we'll do that again, and one more time. Whoops, I hit the wrong button there. There we go. I need to hit factorial. Okay, so now you can see our calculator's got it in there correctly. When you hit enter, you get 3,780. All right, go ahead and do number 14, and that'll be it for this lesson here. All right, let's see how you did. So there's 1, 2, 3, 4, 5, 6, 7 items. That's our n. 7 factorial. So n equals 7. Let's see, we have P would be our repeated O's. We have 2 of those. So 2 factorial, we're going to divide out our O's, repeated O's. And then we've got some S's. 1, 2, 3 S's. So in this case, our Q would equal, I'm just looking at the formula here. Our Q would equal, because there's 3 S's, it'll be 3, so we're dividing by 3 factorial. So when we divide by 2 factorial, we're dividing out the permutations of the O. And when we divide by 3 factorial, we're dividing out the permutations of S. So we're going to get 420 ways here. All right, and that's it for this lesson.